Here's Precalculus Concept 3C underneath geometric sequences. We're going to use the formula for the general term of a geometric sequence, and there's 3 boxes. So here's box number 1. Let's discuss the general term for a geometric sequence. So we're trying to come up with a formula here that can describe any geometric sequence. So consider the following for just a moment: 4, 8, 16, 32, 64. All right, I use this one quite a bit. The very first term that we can see is the number 4, and it looks like the common ratio is indeed 2, right? To go from here to here, multiply by 2, multiply by 2, multiply by 2, so on and so forth. Okay, so for a moment, right, let's take a look at this second term here. 8, the number 8 can be written as the very first term, which is the number 4, multiplied by the ratio, which is 2 raised to the first power. That's the number 8. Take a look at the number 16. The number 16 is the very first term, which is 4, multiplied by the ratio squared, because 2 squared is 4 times 2 gives you back the 16. Okay, let's take a look at the number 32. 32 can be written as the original term 4 multiplied by the common ratio, which in this case is 2, all raised to the third power, because 2 to the third is 8. 8 times 4 is 32. I'll go one more for you. 64 can be written as the original term 4 multiplied by the ratio of 2 raised to the fourth power. 2 to the fourth is 2 times 2 is 4, times 2 is 8, times 2 is 16, and 16 fours make 64. So now remember, okay, this is the same thing as a sub 2. This is the same thing as a sub 3. This is the same thing as a sub 4. This is the same thing as a sub 5. So do you see a connection between the subscript and the exponent? The subscript and the exponent, the subscript and the exponent, and the subscript and the exponent. Hopefully you do. Hopefully you're noticing that the exponent on the ratio is always just 1 less than what you're given. So therefore, any term that we want can be written as the very first term multiplied by the ratio raised to the n minus 1 power. So this and this, these are related to each other, okay? This is very, very important. This is the general term, or I also call this the fast forward formula for a geometric sequence, and we want to make sure that this is in our notes. Box number 2 is an example. It says, find the 8th term of the following geometric sequence. Okay, so we have the first term is 5, the second term is 15, the third term is 45. I would like to be able to skip up and go all the way and know what the 8th term is. Okay, that's our goal. So we know this. We know that a sub 8 has to be the very first term, a sub 1, multiplied by the common ratio to the 8 minus 1 power. So plugging in what I know over here, I know that a sub 8 has to be the very first term, which is 5, multiplied by the ratio, which happens to be 3, because each time I'm multiplying by a value of 3. And I'm going to raise that to the power of 7. So I need to figure out what 5 times 3 to the 7th is. It's okay to use your calculator on this. So I would take my calculator out and I'd plug it in. Let me show you how to do it. I would go 3 to the 7th power first, and then I would multiply my answer by the number 5. And I'm getting 10,935. So therefore, the 8th term would be 10,000, I forgot what it was, 10,935. 935. Okay, box number 3 is a U-try. Find the 7th term of the following geometric sequence: 2, -6, 18, ... Remember, this is the very first term, this is the second term, this is the third term. I want you to fast forward all the way up and tell me what the 7th term has to be. Hopefully you got the right answer, but here's how you do it. We want the 7th term, so it's going to be the very first term, which is the number 2, multiplied by the ratio, which is a value of -3, all raised to the power of 6, because it is always 1 less than the subscript that we were given. When you run this through the calculator, you should get 1,458. If you're not getting this positive answer, you might be doing something wrong in the calculator, so make sure you ask about it. The correct answer is 1,458.